These videos came from two brand new AI video models that landed within days of each other. This one came from LTX-2.5 and this one came from MiniMax H3. Both models can run locally, both generate video and audio together, and both now are available through ComfyUI. Today we're going to keep this simple. We're going to look at what each model is supposed to do, open the basic ComfyUI templates, and look at a few first generations. I'm not going to pretend this is a scientific benchmark, and I'm definitely not going to declare a winner. This is a first look at two different models and the things I want to test next. So let's just jump into it. MiniMax H3 was released at the beginning of August, and LTX 2.5 followed a little over a week later. That makes this a really interesting moment for local AI video. We no longer just asking whether a local model can create a short moving picture. We are starting to ask whether it can understand a scene, maintain a subject, follow a sequence of actions, generate usable audio, and eventually fit into a real production workflow. The last part is what interests me. I don't just want a 5-second demo that looks impressive once. I want to know whether these tools can help me create repeatable characters, B-roll, effects, transitions, product shots, and eventually complete pieces of a YouTube production. LTX 2.5 and MiniMax H3 approach that problem from different directions, so let's start with LTX. LTX 2.5 is the newest open weight model from Lightricks. It is designed for local execution, and it can generate synchronized video and audio from text, images, or video inputs. One of the headline features is native multi-shot generation. In plain English, that means a single generation can contain more than one connected camera shot while trying to maintain the same character, environment, lighting, visual style, and voice across the cuts. That is a much harder problem than creating one continuous shot. It is one of the first things I want to explore in a deeper video. Lightricks also says the distilled version has been improved. A distilled model is meant to use fewer steps, less compute, but the trade-off is normally a loss in quality or prompt accuracy. The goal in 2.5 is to keep more of the full model visual quality and motion prompt adherence while still making generation practical. The other new feature with an interesting name is diffusion fidelity rendering. Instead of treating every part of the scene as if it needs the same amount of work, the model can allocate more of its compute budget to visually difficult moments or less to simple moments. At least that's the idea. But what I want to know is whether that produces cleaner details and fewer breakdowns in real generations, especially around faces, hands, moving objects, and complicated backgrounds. Now let's look at the basic workflow. I have ComfyUI running locally on my Spark. After updating ComfyUI, the LTX 2.5 appeared in the template library. For this first look, I'm using the basic text-to-video template. I am deliberately not rebuilding the workflow or adding any stack of custom nodes. I want to see what someone gets from the supported starting point. At the top level, the important controls are the prompt, the video size, the duration, and the generation settings already supplied by the template. The template may look simple from here, but some of these large nodes are subgraphs. If I open one, you can see the actual model loading, prompt encoding, sampling, audio generation, decoding, and output stages underneath. You don't need to understand every connection before running the template. This is the point of having an official starting workflow. For this first run, I'm staying close to the supplied example. I want a baseline before I start changing samplers, resolution, and step count, or prompt structure. When I cue the workflow, ComfyUI loads the text encoder and video model, processes the prompt, creates the video and audio latents, and then decodes the results. This is running locally. There is no per generation token charge, but the real cost is generation time, memory, storage, and the time it takes to learn what settings produce reliable results. Well, for a first run, my immediate reaction is surprisingly coherent. The specific things I'm watching for are motion consistency, facial and object stability, how well the sound matches what is happening, and whether the video holds together all the way to the final frame. I'm not drawing a final conclusion from one seed. This is simply our baseline. Now let's move over to MiniMax H3. MiniMax calls H3 a general purpose omni-modal generation model. In practical terms, it can combine text, image, video, and audio as multimodal context, then generate a video with native stereo sound. The local released H3 base model can generate between 4 and 15 seconds of video at 24 frames per second with native stereo audio. The default local output has a shorter side of 768 pixels. MiniMax also demonstrates a 2K workflow, but there is an important distinction here. The local open weight release contains H3 base, the full context IR prompt processing system, and the 2K registration stage rely on MiniMax's hosted services. So I would not describe the default local ComfyUI workflow as a complete local 2K pipeline. That does not make the local model uninteresting. In fact, H3 base is the part I'm most curious about because it gives us native video and stereo audio without paying for every local generation. There are also two main model families. The first can work from text, a first frame, a last frame, or both a first and a last frame. The second is a reference model. It can use a combination of reference images, videos, and audio that open the door to subject references, motion references, voice references, video editing, and much more complicated workflows. We're not doing all that today. Today, we're opening the simplest template and seeing whether the foundation works. Just like LTX MiniMax H3 now has native support and official templates in ComfyUI. The workflow is larger because H3 itself is a large model. Transformer is roughly 33 billion parameters, and its text encoder is based on a large vision language model. That makes memory management and model loading part of the practical story. A model can produce excellent examples, but it also needs to be usable on the hardware people actually own. Again, I'm leaving the basic workflow alone for this initial run. I want to establish what the official template produces before optimizing it or adding community tools. My first reaction to this result is pretty impressed. I'm looking at this video and I'm excited. I'm paying particular attention to instruction following, the relationship between the sound and the picture, motion stability, and whether objects remain recognizable throughout the shot. The most exciting part of H3 may not be the basic text-to-video generation. It may be what happens when we start feeding it reference images, reference videos, and audio together. That deserves its own focus test instead of being squeezed into the end of this introduction. After looking at these first workflows, I don't think the useful question is simply which model is better. The more useful question is which model is better for a particular job. LTX 2.5 interests me because of its local workflow, the improved distilled model, diffusion fidelity rendering, and the possibility of generating connected multi-shot scenes. MiniMax H3 interests me because it was designed around multimodal references, native stereo audio, first and last frame control, and much more complicated reference-driven generation. These strengths overlap, but they are not identical. The default templates also don't tell us everything. The output cannot measure identity consistency, prompt reliability, generation speed, memory requirements, or what happens across 10 different seeds. So I'm treating today as the beginning of the test, not the conclusion. Here's what I want to test next. First, subject and identity consistency. Can either model keep the same person recognizable across multiple shots and multiple generations? Second, dialogue and lip synchronization. Native audio is impressive, but is it controllable and usable? Third, image to video. Can the model animate a carefully prepared starting image without destroying the face, background, or important details? Fourth, prompt adherence. If I describe a sequence of actions and camera moves, how much of that sequence actually appears? Fifth, generation time and memory use on the Spark. A model has to be practical and not just technically possible. And finally, production value. Can either one create footage that I could genuinely place into a YouTube video, rather than something that only works as a model demonstration? These are the tests that'll tell us where these models belong. So that is our first look at LTX 2.5 and MiniMax H3 running through the basic ComfyUI templates. Both are new, both are still moving quickly, and I expect the workflows, quantizations, and community tools to change almost as fast as I can test them. Let me know in the comments which deeper tests you want to see first. Should we test subject consistency, lip sync and dialogue, image to video, multi-shot generation, or the reference workflows? I'm leaning towards reference workflows, but I want to know what would be most useful to you. If this helped you understand where these two models fit, subscribe and check out the local AI and ComfyUI playlists on the channel. Every follow-up test will be added there so you can find the complete series. Thanks for watching, and I'll see you in the next one.